So, number one, graph y equals 2x squared minus 12x plus 19 on a graphing calculator. So 2x squared minus 12x plus 19. Using a window -2 to 8 and a y window. So just getting you accustomed to the windows that you should be using. So on my x-axis, -2 to 8. On my y window, -5 to 5. And then graph that. And it wants us to find the vertex. So I want to make sure you guys know how to use the minimum feature. My favorite menu is this calculation menu. So second trace brings you to calculate, and a minimum is option 3. The calculator is now showing a cursor, which coincidentally happens to be near the minimum, and it wants a left bound and a right bound. So I'm going to scroll my cursor left, so it's to the left of the minimum, and I hit enter once, and then scroll it to the right of it and hit enter once. And when I hit those enters, these things showed up, which pretty much gave my calculator a vertical window to say, okay, between these two arrows, where was the lowest point? So when it says guess, you can ignore that, or you can bring your cursor and guesstimate where it is and hit enter. And you get 3, 1 as being the minimum point. That's the vertex, 3, 1. Then it wants us to graph this next one, which is absolute value. So y equals, and just a little bit of a reminder on how to get to the absolute value is under your math key, math, and then over to number, and there's your absolute value, and then x plus 12, and then come out of it. What window allows you to see this general V shape upside down? So if I just zoom 6, by the way, if I hit zoom 6, that's going to bring me back to the -10 to 10 standard kind of very centralized window. So I use zoom 6 a lot just to recenter myself. And I'm seeing this. And based on that that's upside down, I'm going to guess that I have to go this way a bit. So I'm going to move further left over towards this side, which means my x-axis has to be more of a minimum. So maybe I take my window and make my x's show me from -20 to 10 and see if that does any better. Perfect. So that there's a lot of answers to this, but the -20 to +10 window shows that. Okay, solving something on a graphing calculator, like worst case scenario, you don't know how to solve something. You can just, this is one function, this is another function, make sure you can figure out the answer from that. So I'm going to plot both of those, x to the third plus 5, and then x squared minus 7. Again, I'm going with zoom 6. Here's my cubic function, and here's my squared one. Now, they cross once that I see. I don't see this one, but it might be there. I'm going to go up and look for that a little later, but let me find this one quickly first as long as I have it on my screen. Second, trace again, this calc menu. Option 5 is intersect. We want to use that a lot. So first curve, it's got me scrolling along the cubic function, so I want to select that as my first curve, and I only have 2 curves in here, so select this one as my second curve, and then the guess again, you can go right to the point of intersection and enter. And since it's solving for what variable x, our x is the answer. X equals -2, and you can go ahead and see if that works. -8 plus 5 and 4 minus 7. Yes, those are the same thing. But there's something else that's potentially happening up here. So I need to mess with my window to see up there. Maybe I'll go up to 50 and see if that's helpful. Now I'm not going to see as much of the detail down below. Oh, actually no, this is steeper and this is going out. So these are just going to continue to spread further and further apart. So I think I only have one solution, but at least I checked up there to see. All right, determine whether each equation defines y as a function of x. Okay, so if y is a function of x, you can get y all by itself. And there's only one output for every input. So no matter, if I put an x in there, let's say 1, 4 minus 1 squared is going to give me a single and only one answer of 3. So an input of an x gives me one and only one y output. Whereas over here, if I solve for y by subtracting x squared, and then you have to square root both sides, that gives me plus or minus this right here. Now if I plug in 1, an x coordinate of 1 is going to give me 4 minus 1 is 3, square root of 3, but plus or minus. So it's going to give me a positive root 3, but also there's going to be a point on this image at 1 comma negative root 3. That repetition of the x coordinate repeating itself to 2 different y's, that is not a function. Okay, if we jump to number 5, and we're just evaluating, just practicing this, we're plugging in 2 to 2 squared plus 3 times 2 plus 5. 4 plus 6 plus 5 is 15. F of x plus 3 means plug in x plus 3 for all of your x's. So x plus 3 squared plus 3 times x plus 3 plus 5. I get x squared plus 6x plus 9 for this first bit. Distribute my 3 plus 3x plus 9 and then plus my 5. Combine like terms and I'm done. I get plus 9x. 9, 18 plus 5 is 23. And then lastly, plugging in a negative x. So if I plug in a negative x, I have negative x squared plus 3 times negative x plus 5. An example of when it's incredibly important to lock that up in negatives. So negative x squared gives me x squared minus 3x plus 5. So this one, because it was squared, washed out, but this one became important. Okay? On the back side here, we have express the domain and range in interval notation and set builder notation. So the domain is your x's, how far left to how far right. So my domain is going from negative 2 up until 6. The other thing to think about is parentheses or brackets. So do we actually reach negative 2? The answer is no, because that's an open circle. It gets all the way up negative 1.999999, but it does not actually reach negative 2. So that's a parenthesis, and that's a solid endpoint, so it does actually reach an x-coordinate of 6. Okay, that's interval notation. Set builder notation would be the set of all x's such that negative 2 is less than x, and x is less than or equal to 6. So that less than or equal to is kind of reflective of the bracket, and that strictly less than is reflective of the parenthesis. So interval notation, set builder. In the range, low to high, the lowest is negative 3 up to 4, including negative 3, again, because we have a solid dot, but not including 4. And so our set builder notation would be the set of all y's, such that negative 3 is less than or equal to y is less than 4. And then I asked this question, what if there were arrows on the end with the 6, negative 3? So if that were to continue further, your domain would be from negative 2 to infinity, still not including negative 2, but going to the right forever and ever. Set builder notation would be the set of all x's such that x is greater than negative 2. And if it was the range, the lowest would be negative infinity to the highest would be 4 and not including 4. So that would be the set of all y's such that y is less than 4. And infinities always use parentheses, and it has to go smallest to biggest, low end to high end, low end to high end. Okay, so last one here is a word problem. We have a function that's modeling the average number of paid vacation days each year for full-time workers at medium to large U.S. companies after X years. So X stands for the number of years, and F of X is the average number of paid vacation days. Graph the function on your calculator. Okay, so I'm just going to type this in, negative 0.016 x squared. And always, before just looking at the graph, let's think about numbers that make sense. X is the number of years. Okay, so for a window, 0 years at a company till, 40 years at a company might be worthwhile. But you certainly don't need negatives. And it's giving you the number of paid vacation days. So nobody has negative paid vacation days. So anywhere from 0 paid vacation days to 4 weeks, 6 weeks vacation. So 6 weeks vacation, times 5 working days, maybe that would be 30 work days of vacation. If we need to change it from here, we will, but let's see what that gives us. Okay, so explain whether this is a function. The answer would be yes, because it's passing the vertical line test. Find f of 5. So again, these features. F of 5 essentially is going to mean the number of paid vacation days if you've been working at the company for 5 years. So again, we know that we could just plug it in, but rather than re-plugging in all those numbers, let's pretend we had to do like 10 different values in a row. Second trace, and then value. You'll just type in x equals 5, that's what you want to know, and there are 12.75 vacation days. So interpret its meaning. After 5 years, you have that, 12.75 vacation days. And then lastly, for what value of x is f of x equal to 20? So 20 equals all of this. The best way to do that is kind of with a system again. So keep this function in there, but also put in a second function of just y equals 20. It'll just be 20. It's just going to be a flat horizontal line across. Okay? So for what value of x is f of x equal to 20? Well, it actually happens twice. I think I need to extend my window and move further over, so that's going to the right, which means my x-axis should go higher. So x max, I'm going to go 50 years, pretending someone works for 50 years at the same company. Okay, so I wonder if this number doesn't make as much sense. They did only say for what values. They said single value. It also probably doesn't make sense that if you're at the company for a long time, your number of vacations yearly comes down. So maybe we'll get to that conversation here in a minute when it says what windows make sense. But for what value of x is f x equals 20, we're going to trace for the intersection there. Second trace. Option 5 is intersect. Get over here. Enter, enter, enter. 17.8. So we'll say approximate, which means after 17.8 years of work, 20 vacation days. So what windows make sense? Now in hindsight, I'm going to get rid of this 20. I kind of think that we only make sense up until we get to the maximum, because why would anybody lose vacation days because of seniority and longevity? I don't think that that's realistic. So maybe if I find that maximum, second trace, find the maximum. I want the maximum between this point and this point. So left bound, I'll hit enter here. Right bound, I'll bring it over here until I'm certain it's turned around. And then the guess I can ignore and just hit enter through. 29.06 years. So maybe, well, that's really the number of years before it starts turning around. So maybe this model only makes sense from 0 years to 30 years. And then on my y-axis, 0 vacation days up until 22. We can just go a little bit above that, 25. I think maybe that makes the most sense, because then you never lose vacation days unless they really want to get rid of you somehow. But I think that may be the conversation there. So here's your homework and use of the graphing calculator for 41 to 51. A lot of this was making sure we know how to use our calculators when the time permits this year.